Welcome to qnawire.
This is problem 12 of chapter 23. For this problem, we are given two wavelengths. So let's label them lambda 1, which is going to be 656 nanometers, and lambda 2, which is going to be 410 nanometers. Now let's just go ahead and convert both of these to meters. And these wavelengths, they are going to interact with the diffraction grating with the following number of lines per centimeter. We have 5,300 lines per centimeter. Now let's go ahead and convert that to lines per meter. So that comes out to be 530,000 lines per meter. The question is asking for the first and second deflection angle. And to do that, we're gonna have to convert this number of lines per meter into the separation between the slits or the holes in the diffraction grating. So D is given as the inverse of that N. Notice that the units here are 1 over inverse meters. So then we get 1.887 times 10 to the negative 6 meters. That's our D. And we are going to use the formula for constructive interference, D sine theta m equal to m lambda, where m is equal to 0, 1, 2, 3, etc. Okay, so we're looking for the first and second order angular deflections for both wavelengths. So we are going to solve this equation for theta m. We divide both sides by d. So we have sine of theta. It's going to be equal to m lambda over d, and then we take the inverse sine on both sides. So our equation is going to be theta m equal to arc sine of m lambda over d. So we want the first and second angular deflections for these wavelengths. So let's go ahead and do the first case when lambda is equal to, lambda is lambda 1. So lambda is just equal to this. Theta 1, let's just go ahead and copy this expression here. And let's change out the subscripts. It's going to be 1 here. 1 times the wavelength, which is this, divided by the distance between the slits in the diffraction grating, which is this. Plug this into your calculator and make sure that it's in degree mode, and you should get approximately 20.3 degrees. For the second order deflection angle, we repeat this process. Again, the only thing that's going to change is this m is going to go from 1 to 2. So let's go ahead and copy this, and let's just change that number. And this comes out to be 44.1 degrees. So this is the case when lambda is equal to 656 nanometers. We're going to do this again for lambda 2. So it's going to be the same exact calculation, just lambda is going to change. So let's go ahead and just copy this. And let's go ahead and change the lambda. So now we have lambda 2. We're going to use the same equation, except now it's going to be with lambda 2. Let's go ahead and make sure we change this value. The angle for the first deflection should come out to 12.6. And then for the second deflection for this wavelength, it's going to come out to 25.8 degrees. So that concludes problem 12.